Hey boys and girls, my name is Jan. Welcome to another video on this channel. Today we're gonna switch things up. We're gonna jump into action right away. We're gonna print something and afterwards I'm gonna explain what has changed. And let me tell you, it changed a lot.
Da 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 da.
I have no idea how much you can understand of what I'm saying right now, but this is literally the second real print, and of course we're going pretty fast for the second print, I guess. So this is limited to 200 millimeters a second of printing speed with 20k accelerations, and we're printing in calibration cube. So I sliced it with 400 millimeters, but I have the speed factor down to 50% to, increase the chance of this print finishing. It's estimated 6 minutes or something. So let's see what we got. Alright, so that's pretty much the best I can film this with my smartphone setup here. As you can see, these straight walls are looking pretty damn good. The top part where it goes out a bit is of course because it's going from straight infill to a different cooling setup or a different layer time. On the XY side, you can see there is a bit of ringing, but it's actually a decently fast print. I don't use input shaper at all. This is just purely mechanical stuff, and this is like a 6 minutes print, I guess. Yeah, 6 minutes 20. I think we have to deal with the retraction settings. There's something off. It is very likely that this hot end in this configuration isn't working with standard retraction settings. I used the standard template. And when you look at the top fill, it's actually not bad at all. There's a bit of separation from the most parameter. Let me get a caliper for checking the dimension. This is the Z part, so height. Maybe 1/10 of a mil on the plus side. Pretty much spot on. And 1/10 under. Yeah, I think let's call that good. I don't even think about messing with calibrating that. That seems to be spot on. maybe, just maybe, we have a little bit of a skewed image. So I don't think this angle is a 90 degree. We could check that on the surface plate. But again, it's not too bad, and the error will come from me not having this centered all the way, so the math doesn't adapt perfectly. I just did this with a tape measure. So there is a way more sophisticated way of finding true center, and I think then this problem is not existent anymore. So what we're going to do next. Either way, I'm going to change colors. Filming this white stuff is pretty much a pain. We're going to change that to something with way more contrast. Now we're going to have a look at the hot end setup. Quite a lot of things happened there. I guess then it's time for its first Benchy and see where we end up there. What you're looking at here is the state of the hot end / Z-axis assembly. My design goals with this were to have a reliable platform to do tests with. This is by no means something that is done. In fact, this will only serve the purpose of bridging the gap to the next full-blown iteration, which will have full CAD, full simulation, etc. But I want to keep going with the motion system and do first printing and do some cooling testing, etc. So this is just for now. Yeah, it kind of will be thrown away afterwards, I guess. But it has delivered so many valuable lessons and things we can incorporate in the future version. It had a great purpose. So having a closer look, there's nothing changed in the Z-axis assembly. There's still that NEMA 17 that's driving this up and down. I did put in 4 of the Misumi linear bearings. And then what I did to incorporate all of this is to print an adapter plate which screws onto the existing mounting holes and just adapts all of this onto here. Having a look at the central piece, this is basically untouched. Wait, that's not true. Let me explain. First of all, I just wanted to get rid of that misalignment of both of these, so I grinded off a few millimeters of that heat break between the 2 heater blocks to have them both clocked at the same orientation. And then, which turned out to be a mistake in the end, I upgraded to a double heater system, which worked flawless. I mean, the first extrusion tests were also successful, but when I cranked up the flow rate, it actually squirted out a lot of material down here. And what ended up happening, I was a bit in a rush trying to get this all done, etc. You know what it is. And I actually drilled the second hole for the second heater just a tiny bit too close to the actual channel. It's just 1/10 of a millimeter. I nicked this hole, and with low extrusion forces it actually was tight. But once the pressure started rising, actually material was coming out of there. Yeah, but the easiest solution for now that works is I got on the lathe and turned down some PTFE Teflon, which is like 500 mil oversize. Used the press to actually press it in there, and since the heat elongation of that PTFE is higher than the aluminum, once heat is applied, it actually just shuts that hole down, like repairing a tire. But that brings me to the problem that actually the heating capacity of that isn't big enough, kind of working 100% to maintain a constant temperature with the cooler installed. The cooler itself, it's just an adapter to have shop air go into here. There are channels to both of these sides. You'll see 2 outlets. They're meeting somewhere in here. That's, I mean, the CAD drawing is specified a point 5 millimeters down of the nozzle, and it actually will do quite some airflow. And I can just control it with this pressure regulator. So let's talk materials for a second. I had to drill 2 holes in that upper heating block, which accept an M4 screw, which is then screwed in here. To have like not everything here melt, I insulated everything with PTFE washers. So this aluminum plate, this is heated up for like an hour, and I can still touch it. it's like 40 degrees or something. But the heat doesn't travel into the printed parts, and I also have a very small washer down to this part, and yeah, these are holding up fine, and this is a really rigid setup. The motion system isn't introducing any momentum into the rest of the machine. I mean, need way more G's to actually make an impact on there, but this is pretty much as stiff as it has to be to not introduce any ringing or wobbling from the Z-axis. Yeah, the motion system is pretty much as you saw it the last time. This is just some masking tape with glue stick on top. The test print actually did stick pretty well to it. Enough talking. You saw what we're printing with as of right now. I'm going to slice up a Benchy. I tried to do a 10-minute one. Let's try that and see if we can do a complete print without it failing. I sliced up something which will end up like 11 minutes or something. Let's get a benchmark. It will look crap anyway. For proper testing, I'll have some retraction tests, temperature tests, whatever. You know the deal, what it takes to calibrate an actual printer. But yeah, for video purposes, I know you guys want to see a Benchy, so let's do that as a third print. Alright, that's looking a lot better. Slowly gonna ramp in the cooling. This is still 25% movement speed. I let it run for a couple of seconds just to see what it's doing. And even the movement speeds are down by 25%, but we're still at 75 to 50k accelerations. For a Benchy, that doesn't make that much of a difference. We're only limiting the printing speed to 150 millimeters right now. I mean, Slicer's given me an estimate of 20 minutes. Let's go back to 50%. This is maximum speed of like 300 to 400 mil, depending on what type of line it is doing. Going to increase cooling even more. Our first Benchy just finished, and so apparently this finished in 9 minutes 47, including the prime. I have to see what that took of the time overall. So let's say this is a 9-minute Benchy. I wasn't expecting that, to be honest. And yeah, there are some obvious things that are not perfect. I also think we do have a layer shift, but let's check that. Yeah, maybe. For this testing, I do have the motors turned down to like a third of what they're capable of, just to have a reliable setup that doesn't overheat, etc. Obviously, this is a massive problem. But what I wanted to check is bed adhesion. Yeah, I mean, it did stick kind of well, but I guess for going 5 times the speed we need more. Again, no input shaping. This is just raw with loose cables. And what I originally wanted to tell you is how easy it is to bend like that, and the more weight we get on top, the bigger the leverage actually is to have that lifted up. I get comments all the time on what I want to do with it, and should I attach magnets or something, but let me just quickly explain this again. There will be an additional plate on top of here that will hold that down, and it will be clamped down, and the inner part of the air bearing will be lapped to a pretty close tolerance. So, and it will just move in here. So basically this will stand still and the bed under it will just move. Just the bed will peek out of it. And then we don't have to worry about all that tipping forces. Originally this was planned with having the motors here and there would have been like this part underneath, but obviously you can see it doesn't fit right now. I don't want to go into planning all of this before I don't even know what the setup in the end will look like, but this is pretty darn promising. I mean, just have a look at it. That's a 9-minute Benchy. It doesn't even look too bad. I mean, of course, have you seen the latest Peugeot MK4S video on that Benchy, sub 10 minutes in bonkers mode? It's far away from that, but there seems to be the layer shift happening here. There are some cooling issues, but once I crank the cooling up to its maximum up here, it's looking fine. Also, stringing got a lot less in those parts. Yeah, bridging can be tuned, but also I have to investigate all the extruder related stuff, because I was running 240 degrees on both heat zones. That may be way too warm for what I was actually requesting of material flow. I've had a peek at what Clipper was telling, and I think it's around 50 cubic millimeters a second, which isn't that much. So maybe 230 or 225 degrees would have been the sweet spot for this. But if we want to go like 250 cubic millimeters a second, we need to go to 250, 260, to 80 degrees or something. We need to decrease the layer time up here. Top infill looks okayish. I have to look it up in the video where I got to... Is it from here? 25% speed to 50%? Then this looks way better. So obviously this system will have resonant frequencies, and we'll find all that out once we go with the accelerometer and tune the input shaping in Clipper. So yeah, what do you guys think for a 9-minute third print? A few things I've noticed. The times in the slicer don't really add up. If you have a look in here, the sliced Benchy without the priming etc. is scheduled to around 12 minutes, and I was running all of that at 50% speed factor. Then again, it finished at 9:47, including the prime tower. Another thing, I sliced this guy without the priming tower, and it tells me it's 11.85 grams of material. When I put it on the scale, got like 11.1 grams of material in here. That means we do have like 6 or 7% of under extrusion, which is not that bad considering that I didn't clamp down this tensioning arm at all. Yeah, let me figure out what we print next. I don't think we're gonna go for all the boring calibration stuff. Let's do one more, I guess. Let's see how far we come today. Alright, I made up my mind. We're gonna print another Benchy, babysitting it real slow in the first layers, then cranking up quite a bit, 30% more max speed. Also going up with accelerations quite a bit, like 150k for G0 moves, 100k or up to 150k for infill moves. I hope these steppers do that. I have them set to 2 amps. If I go higher than that, they won't make the time. We're gonna stay at 240 degrees for both heat zones, since now we're requesting a lot more material. Maybe that adds up. Also, I changed the retraction settings. I doubled the retraction length and put in a bit more speed. So let's see what that changes. It still tells me it will be 12 minute 35. If I extrapolate that from the previous one, I think we're more in the 5-minute region, but let's see what happens. Idiot. I mean, how was that supposed to work? It was as loose as that, so let me fix something. Alright, let's have a look at what happened here. Still, no input shaping. So, I was having a look at those numbers. It made it 12 mil high. Took around 2 minutes 30 to get there. So, I guess this would have been somewhere in the neighborhood of 5 to 6 minutes. And of course, it doesn't look good, but you can analyze way more. Also, I got way more information than you. I was starting with 240 degrees down here, and I could see once I gave some percent to the cooling, I could see serious under extrusion, and even with those kind of speeds, sometimes it is requested 150 cubic millimeters a second from the extruder. With just the one heating element in the melt zone, it can't really keep that up. Then I bump up the temperature to 250 and then 260 degrees, and that is what you can see here in the upper part. Lots of that did look bad because the layers down there weren't there in the first place. So once it catched again, if you just look at these few millimeters, it doesn't look great, but you can see a lot of positive things happening here. So we have to get up with the temperature. What ended up happening is that the software or the mainboard gave an error because the heater was cranked to full blast, 100% duty cycle, but there was no rise in temperature, so it assumed there was a cable broken or something and shut down for safety reasons, which is a good thing. So I am debating if I leave it as is for now. That would be the smart move, because there are so many issues right now. This one is pretty loose and I can tighten it further. I need to address so many other things, but also I would like to do more printing in this video. So if I would have any chance to do a second heater cartridge in here, I mean that's where the second one was supposed to go. I was talking about my messing up there. Then we would have no problems. So what we can do is, these are rated for 12 volts. If we increase the voltage, right now they are running at 18 volts and they managed to do that. We can crank them up to 24. The power goes up by the square of the voltage. So yeah, fuck it. Let's just put 24 volts on there, dial it up to 260 degrees and give it a last go. Yay! Awesome! Whoa, what a rush. Feels like, yeah, driving a submarine all by yourself and you have to dial all the knobs at the same time. Everywhere is stuff leaking, it's loud AF. What a fun project. Let's see. Yeah, I think adhesion for right now is okay. Maybe you can see or have seen it in the footage. The first layer was squished. I have to replace this. This is warped and find a long-term solution, as with any or most other things here. So there is a layer shift, but eventually the print stopped because of overtemp error from one of the TMC drivers. I would like to know what the difference is between these areas and everything above, because I didn't change too much. It took me some time to get cooling to 100%, but it isn't looking too bad actually. Of course, not perfect, still no input shaping, still no whatsoever, but this would have been a 5-minute Benchy. A few parts of it actually do pretty damn fine. I had the hot end at 260 degrees throughout the whole test. It isn't able to keep up, but that's for various reasons. You can see at the end there is plastic squishing out, so my PTFE plug isn't working at those high pressures. And still I'm working with a pusher assembly from 2016, which is just there because I had it on hand. Let's upgrade that to some high-tech 2024 version, and yeah, we can push a lot harder on these heat zones. On the upside, stringing seems to be a lot better. It did handle 24 volts, but there have to be so many upgrades done to the system to actually go further. But this was a very interesting and needed day of testing, and I got so many information out of here. I'm wondering why the first 2 millimeters look so good. I mean, have a look at all those details here at the butt of the boat. Doesn't look too shabby. Of course, retraction settings need some dialing. We can have a look at pressure advance in Clipper to get rid of all these artifacts. The top fill isn't actually too bad. I think this is some pretty interesting outcome for today. Let's add that up here. 1, 2, 3, 4, 5. I'm pretty proud of that. This ain't a very scientific approach, but let's just do a very quick test what the cooling capabilities are and set this to a reference. On the X1 Carbon, I got this tray with like 5-6 millimeters of water down there, and we're gonna crank up the part cooling fan. This is 50%, 70, and 100. So you can see it makes a pretty good dent, and the water actually reaches to the bottom of the tray. Alright, let's do the same thing on our shop air cooling system. I've set up the same test on the CMM. You can see the pressure regulator, and this is the same amount of water in the tray and roughly the same distance from the water. So I'm just slowly going to crank this up. It is limited by this 4 millimeter. We could go more, but I have to at least make it somewhat more efficient, because as of right now it's producing way more noise than it needs to and is probably not efficient enough. I'm just going to go through the whole cycle. Keep in mind that we're using shop air to do this, since it has been compressed before and now it's been released to atmospheric pressure. It actually contains a lot less energy in heat. Any reference system will take ambient air temperature of like 20 degrees and put it on here, or in case of an enclosure, maybe do 50 or 60 degrees C and blow it on the part. This is way cooler. What up next? Gonna do a few more iterations on this, maybe do a little bit of flow simulation to max this out, to get the noise level down. Yeah, but I think the cooling capabilities are way up there, and let's see if I can come up with some scientific approach on how to measure the performance over different systems. What do we take away from this video? Each minute of testing that goes by, my respect for all the other people that already did manage to print sub 5 minute benchies is growing and growing. It's a pretty tough business. So to set all of this here in context, for everyone that was awaiting, yeah, we suddenly go 3 weeks into building something like that and we're gonna go sub 1 minute benchy, ain't gonna happen. In this particular case, nothing is proven. The motion system is a complete one-off. I haven't seen anyone doing stuff like that. The extruder is a complete one-off build. Yeah, just being hacked together as a prototype. The firmware and G-code wise has to be manipulated big time. Just to do these 5 tests, I had to do 1 complete day of testing. What I have to do next is to get some proper routines going. I already did the CAD for some kind of a leveling sensor, have a proper Z height, because that's quite a pain to go with a feeler gauge, etc. I need more power on the whole extruder setup, I need more pushing force, I basically I need more of everything. As I said in an earlier video, it doesn't make sense to plan for the final iteration. It won't work anyways, especially when you have so many untested components and thoughts in your mind. We have to go step by step and by improving a little bit each and every time. And we've already managed to do a 9-minute Benchy, which is for a third print of this system actually insane. Let's say I would have active cooling on the stepper drivers, also a 6-minute Benchy would have finished at the same day. So the rate of improvement is kind of there, and yeah, but shaving off minutes and minutes and then seconds after seconds will take a while. But it's been extreme fun working with this kind of setup, experimenting, finding stuff out, and just giving the information for everyone else so everyone can use this for their own purposes. One last thing for today. Last time I mentioned, or we talked about the name of the machine, the MinuteMan. I actually talked to the guy that made the comment. It's a guy named Leroy from Germany. I won't have the proper time to go into what I'll actually be sending him, because I want to do a video about the CMM itself and play around with the air bearings. I don't have the time for now to do that. Let me know in the comments what kind of conclusions you would draw from today's tests. What would you be doing next? Which kind of iteration is the most important and has priority? What else can we learn from all the tests I've done today? For me, it would be pretty interesting to not just have my 2 eyes on it. Just post in the comments whatever you took away from it. And I think with that, bye-bye.